Okay, so in this video, I would like to talk about adding a very simple crossfader to the mix module. In this case, I made a copy and I called it mix fade, but it is essentially the same thing as the default mix module. Since I am still trying to figure out aleph, some of my explanations might be a bit difficult to follow or incomplete, and I am hoping to get better with this as I gain more experience with aleph and become more comfortable explaining the code and how it works. I guess I would like to begin by examining what a crossfader actually is. I know this may seem really obvious, but I guess the reason that I wanted to go through this is to illustrate how I deal with the process of having to come up with functionality or ideas for aleph in order to figure out how to implement them in code. Especially because of the characteristics of C, I just find this process to be helpful. So I always try to begin by thinking about all of the component parts and concepts behind how something works. In addition to trying to picture what is going on, I often look online for an explanation that sums up how something works in an easy to understand and visualize way. This time, I found this really great site, which I will try to remember to link in the description, that explains how a crossfader works. It says a crossfader essentially functions like two faders connected side by side, but in opposite directions, and it allows a DJ to fade one source out while fading another source in at the same time. In addition to being concise and easy to understand, this description really helped me to visualize what I needed to do to create a crossfader in this case. So, essentially, we need to fade one channel or input out by ramping down, while simultaneously ramping the other channel or input up. The fact that the change should be audible tells me that I need to apply the ramps to volume. So, armed with this concept, the next task was coming up with, or manipulating the code to enable addition of a very simple crossfader to the mix module. The first thing I did was to examine the monome DSP dev tutorial. Although it talks about adding a master volume control, the process is very similar, and makes use of many of the same steps. So, let's examine the files. Again, I created a copy of mix and renamed it mix fade, so we are in the mix fade directory. And I've already compiled it, so I have all of the files that are generated after doing make deploy. I guess the first thing that I did, sort of working in a bit different order from the tutorial, was added a new fader parameter, which I just called fader value to params.h. The next thing I did was open params.c and copy one of the CV types. I changed the label, but left the type as fixed. I also left CV max and basically left all of the other parameters unchanged too. Types and other parameters probably do require a bit more explanation, and I do plan to talk about this topic in the future as it comes up. The official documentation also contains a great deal of helpful information on this topic. Okay, so the next thing that we want to do is add the control variable, the fader value that we added to params.h and params.c to mixfader.c. And we want to initialize it to 0. Let's also get some line numbers. Okay, the next thing I did, kind of going back to our explanation of two faders connected side by side, but working in reverse, was to set up two of the amps, to start at opposite values. In this case, I envisioned these two as channel A and channel B. I visualized a default setting where the crossfader was positioned on the maximum setting of the channel A side, and channel A was at maximum volume. I pictured channel B as being at the opposite end of the crossfader, and being set to -infinity, or completely silent. The official documentation contains a bit more information about these parameters, but, originally, they were all set to -12 dB in mix.c. Based on how I visualized the default settings of my crossfader, I set one to max, and the other one is set to 0, so that it will not be audible by default. So, with these settings, every time we load mix fade on aleph, channel A volume will be at maximum, and channel B will not be audible at all. I also realized that, given the way the fading part of the code works, it may have been possible to set this up in a different way, but it just worked better, conceptually, but also for testing, to do it this way. Next, we need to create the mechanism that will allow us to dynamically adjust the volume using the fader value variable. Before we go any farther, I would like to talk about audio routing in aleph a bit. For me, it is a bit difficult. The official documentation does discuss how it works and why they have set it up this way, and, as I understand it, it seems like one-pole filters are used to smooth out transitions so changes, like encoder turns, don't sound as steppy or jerky. I have worked a bit with Arduino, and in a really basic Arduino program, you just have in and out, and it seems, conceptually, a bit easier to visualize. We do have in and out in here too, but they're routed through filters and, what I understand, is an amp that enables soft volume control. In this case, we want to adjust ADC val. And we want to be able to adjust dynamically with fader value. In this case, ADC val 0 would be channel A from the previous example, and ADC val 1 would be channel B. Using these Blackfin intrinsics in this arrangement enables the audible output of A to be decreased, while simultaneously allowing the audible output of channel B to be increased when the encoder mapped to fader value is turned clockwise. Additionally, turning the mapped encoder counterclockwise will increase the audible output of channel A and decrease the audible output of channel B. I tested it, and I was able to achieve the effect I was hoping for. That being said, I realize that this is probably not the best implementation, and I am sure there are other implementations that would work better. I guess based on the way that I envisioned the process, this was the best workable idea I could come up with for now. Okay, so after we've added some code to dynamically adjust the volumes so they work like I envision a crossfader working, the next thing that we need to do is finish adding the parameter to the necessary locations to enable use, mapping, etc. So we need to add fader value to this switch case statement, and set fader value equals v. I think this is what enables us to map and dynamically control the parameter with an encoder. The final thing that we probably should do, and I forgot to say it before, is to add a default for fader value. And I just set fader value default to 0 here. The official documentation can provide more guidance on the specifics of the settings, and, in general, I usually use the tutorials and existing DSP modules as guides for setting up my parameters. Okay. At this point I would like to do a very brief demonstration of the crossfader. Thank you for listening.
Section 1 of Geography and Plays. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Geography and Plays by Gertrude Stein. Sweet tea, Susie Asado. Sweet, 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 sweet tea, Susie Asado. Susie Asado, which is a told tray sure. A lean on the shoe, this means slips, slips, hers. When the ancient light gray is clean, it is yellow, it is a silver cellar. This is a please, this is a please, there are the seds to jelly. These are the wets, these say the sets to leave a crown to inky. Inky is short for